Okay, in section 4.6 in pre-calculus, we're talking about graphing the other remaining trig functions, secant and cosecant, tangent and cotangent. I'm starting with tangent and cotangent. The period for tangent and cotangent is going to be pi over b. So, if the b here is a 1, that makes the period pi. So what it does is it goes from negative a half pi to positive a half pi, and that creates one period or one cycle. And a tangent looks a lot like an x cubed. It comes up, curves through the origin, but approaches these asymptotes. Now that's one cycle. Yes, there are more. If you added another pi, this would be at 1.5 pi, and that would be at pi, and you'd have another one. But anyway, this is what the tangent curve looks like. I'm not going to give you phase shifts on tangent or cotangent, but I am going to have you adjust the period. Here the period, here's the standard one. The period is pi. Next one I'm going to do is a cotangent. So let's look at a cotangent one. If I said y equaled cotangent of x, remember that it is still bx, so the period is still, the b is still 1, the period is still pi. But cotangent has a vertical asymptote at 0 and at pi. And instead of going up, it tends to come down like this. So it's going to hit at pi over 2. But from 0 to pi is one cycle or one period of pi. So that's tangent and cotangent, just the basic graphs. After we do tangent and cotangent, let's look at a secant and a cosecant. So first I'm going to do a cosecant. Cosecant, you need to know, is 1 over sine. So to graph a cosecant, I tend to graph a sine wave. So I'm going to graph a sine wave. You may notice that I'm doing it dotted because that's not part of the actual graph. I just did a sine wave. Sine and cosine, the period is 2 pi over b. So in this case, it would be 2 pi over, what is the b? 1. So that makes the period 2 pi, makes this pi, makes this 0. Wherever the sine is 0, which is where it hits the x-axis, you can't divide by 0, so that creates vertical asymptotes. Now the actual curve itself is going to come off of the sine wave here. Let me make it a lighter color. Sine wave, and approach these asymptotes. Maybe we could get the coordinates here to be pi over 2 comma 0. Except it's not 0. It should be, what's the amplitude? 1. And this should be at 3 pi over 2 comma negative 1. And that makes one period or one cycle of the cosecant wave. Okay, after cosecant, we might look at secant. Secant is 1 over cosine. So this time I may graph a cosine curve. A cosine starts at the maximum and completes its cycle. And again, 2 pi over b. The b is a coefficient on the x, so it's 1. 2 pi over 1 makes this period 2 pi. Makes this pi, makes this half of a pi, 1.5 pi. Again, if you were to extend it, where would it hit over here? Negative pi over 2 comma 0. But wherever the zeros are, that creates vertical asymptotes. The actual graph itself will come off of the cosine curve and approach these asymptotes. So here's one period or one cycle. Again, the amplitude was 1, so that's 0, 1. This would be pi comma negative 1, I believe. And that's a basic cosecant graph. Okay, in this section, I think I'm assigning 4.6. I gave you 5 and 7, which are tangents. 17 and 19, which I believe are cotangents. Then I gave you 29 and 31. 29 and 31 are cosecants. And then I gave you 39 and 40, which I believe to be secants. Let's verify. Yes. So these should be your assignments. I believe it's 2 of each in section 4.6. We're going to do one of each. We're going to do a tangent, number 5. 19 is a cotangent, 31 is a cosecant, and 39 is a secant. So we're going to look at one of each of them. The number in front here really tangent does not, and cotangent do not have amplitudes. So the number in front here, the A, really does not have any relevance unless it's negative. If it's negative, it would flip it. What is the period on this? Period is pi over b. For tangent and cotangent, the period is pi over b. Pi over, what's b here? 1/4. Do you know how to divide by 1/4? Multiply by the reciprocal of 4. So hopefully that makes your period 4 pi. You need to split it equally on either side of the y-axis. How far would it be from negative 2 pi to positive 2 pi? Hopefully this period. Draw your asymptotes and sketch your curve. And there we have one cycle for number 5. Again, I'll be happy with one period. You don't need to give me 2. So again, for tangent, you find what the period is. You go half the period to the left, half the period to the right. Those would be your asymptotes. For number 7, you still have your period is pi over b. In this case, the b is 1/2, right? No, what is the b in this one? B is 2 because it's bx here. So the b is a 2. So that makes the period what? Pi over 2. Now, cotangent goes from 0 and then it goes to where your period ends, pi over 2. You have a vertical asymptote at 0, a vertical asymptote here, and it's going to be flipped over from the other one. It's going to come down and look a lot like this. I think you'll notice I didn't use this 1/2 at all. If it was negative, I might have flipped it to make it look more like this, but since it's not, I left it alone. Okay, we did tangent, cotangent. Now we're going to look at cosecant. Cosecant is 1 over sine. So first thing I might do is sketch a sine wave. Sine starts at the origin and looks a lot like this. However, what's the amplitude on this one now? 1/2. So it's only going to go up to 1/2 and down to -1/2. The period is 2 pi over b. 2 pi over, what is the b here? 2 pi divided by 1/2 makes the period 4 pi, right? So this would be 4 pi, this would be 2 pi, this would be 1 pi, this would be 1.5 pi. Now wherever the sign is 0, like here, here, and here, it creates vertical asymptotes. And the actual curve itself is going to come off of the sine wave and approach these asymptotes. Can you give me the coordinates? Would that be pi comma 1/2? I'm sorry? That should be 3 pi, not 3/2. You're right. Definitely should be 3 pi in the middle here. So what would be this point here? 3 pi comma -1/2. Okay, 31 and 39 is a secant. Secant is 1 over cosine. So I'll probably sketch a cosine curve. Cosine starts at the maximum, finishes a cycle usually in 2 pi. However, what does this negative do? It flips it. So it's not going to look like that. It's going to look like the cosine flipped over. The amplitude would be 1/2. And what's the period if it's 2 pi over b? 2 pi over, what is b? Pi. So that makes this period what? 2. So that means this would be 2, right? Halfway would be 1. That would be 1/2. 1.5, right? How about if you extended it this way? Would that be a -1/2? Okay, now wherever those hit the axes, it creates vertical asymptotes. And the actual curve is going to come off of the cosine wave and approach these asymptotes. So this would be 0, -1/2. This would be 1, 1/2. Anyway, I hope these help. Good luck with the homework.